Good day, sir. Good day, classmates. So, ang topic natin ngayon ay exact differential equation. So, let's say we have m xy dx plus n xy dy is equals to 0. So, kailan nga ba natin malalaman na exact equation na siya? So, it will be exact if the partial derivative of m with respect to y is equals to partial derivative of n with respect to x. So, dito, isiset natin constant ay yung x. So, tas dito naman, constant natin ay yung y. So, ayan. So, kapag ka yung partial derivative ng first term or ng m, at saka yung partial derivative ng n or ng second term ay equals or naging same, naging magkamukha. So, doon natin malalaman na exact differential equation siya. So, let's have example number 1. Y squared minus 2xy plus 6x dx minus x squared minus 2xy plus 2 dy is equals to 0. So, ang first step natin para malaman kung exact equation ba siya is to determine where is the m and where is the n in the equation. So, dito, ang m natin ay ito, y squared minus 2xy plus 6x. Tapos, ang n naman natin ay, ito, isasama natin itong negative na to kasi kasama siya dyan sa equation. Negative x squared minus, so ayan, negative pala. So, i-distribute na rin natin, kaya magiging positive na rin siya kasi negative times negative is equals to positive. So, positive 2xy, positive, negative, negative 2. So, ayan. Kapag nakuha na natin yung value ng m at ng n, so, pwede na tayong dumiretso sa pagkuha ng partial derivative nila. So, ang partial derivative ng m with respect to y is equals to, tapos, di ba dito, binanggit natin kanina na yung x ay gagawin natin constant. So, dito may x tayo, kaya magiging 0 na lang siya kasi ang derivative ng constant ay 0. Tapos, dito ko natin yung derivative ng mga natira. So, ang derivative ng y squared ay 2y. Like, derivative ng negative 2xy ay negative 2x. Ayan, kasi, di ba, constant na yung x, kaya kasama na siya. So, dito naman sa pagkuha ng partial derivative ng n with respect to x, ayan, equal. So, ito ay constant, 0, magiging 0. Tapos, ito ay, ang derivative ng negative x squared ay negative 2x. Tapos, dito, dito, kasi di ba, constant yung y dito. So, ang matitira na lang dito, kapag dinerive natin yung 2xy ay positive 2y. So, dyan, pagkatapos niya, titignan natin kung magkamukha ba sila ng naging sagot. So, ayan, parehas naman. Pero, magkaiba lang ng arrangement. So, gawin natin itong 2y minus 2x. So, ayan, same pa rin naman para makita natin na, ayan o, same sila. So, ang ating, this is exact differential equation. So, let's proceed to example number 2. Let's say we have 2xy tan minus tan y dx plus x squared minus x second squared y dy is equals to 0. So, ayan. So, yung first step ulit natin is to determine where is the m and where is the n. So, m ay 2xy minus tan y. Ang n natin ay x squared minus x second squared y. So, ayan. Tapos, ito-determine na, pupunta tayo sa pagkuha ng partial derivative. So, partial derivative ng m with respect to y is equals, so, ayan, ito ay 2 x. 2x minus, ano ba ang derivative ng tan? Ito ay second squared y. Second squared y. Tapos dito naman, ang pagkuha naman natin ng partial derivative ng n with respect to x. What is the derivative of x squared? 2x. Tapos dito, since yung second ay may katabing y, so ibig sabihin, magiging constant na rin siya. Kaya, kapag dinerive natin yung negative x second squared y, ang magiging derivative niya ay negative second squared y. So, ayan. So, since parehas din sila, katulad ng kanina, yung differential equation natin ay exact. Pumunta naman tayo ngayon sa example number 3. So, let's say we have y, 2x minus y plus 1 dx plus x 3x minus 4y plus 3 dy is equals to 0. So, kapag ganyan yung nakita natin equation, sa given natin ay, para mapadali yung buhay natin, i-distribute muna natin yung mga nasa labas. So, magiging magiging 2xy minus y squared, tapos plus 1. So, kapag ito ay distribute natin dito, ay magiging plus y na lang kasi invisible na yung, ano natin, 1. Tapos, ito na rin yung gagawin nating m. So, siya yung m natin. Dito naman ay yung n natin, distribute natin tong x, magiging 3x squared minus 4xy plus 3x. Yan. So, ayan yan. Tapos, ang susunod natin ay yung kukunin natin yung partial derivative nila. Yung partial derivative ng m with respect to y is equals to, so, ayan. Kunin natin ang partial derivative ng 2xy ay 2x. Tapos ito, negative 2y. Tapos ito ay, ang derivative ng y ay plus 1 na lang siya. Kasi di pa gano'n naman talaga yung derivative natin. Tapos dito ay, partial derivative ng n with respect to x is equals to, ang derivative ng 3x squared, ay bababa mo lang ito, pag multiply mo ay 6x. Partial derivative na, ang derivative ng negative 4xy ay constant yung y natin, so magiging 4y. Tapos ito ay plus 3. So, ayan. So, tapos titignan na natin kung exact ba, kung parehas ba sila or hindi. So, since hindi magkamukha yung partial derivative ng m natin at saka yung partial derivative ng n natin, so the differential equation is not equals. So, hindi sila exact. Not exact. Not exact.
Good day! Our topic for today is exact differential equation. A differential equation is said to be exact if the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. It is known as the TFE or the test for exactness. And to solve for the exact differential equation, we will use the following formula. Number 1 is the partial derivative of f with respect to x is equals to m with the components of x and y. And the second is the partial derivative of f with respect to y is equals to n with x and y components. Now, let's proceed with the examples. And so, yung example number 3 natin ay 2xy minus tangent y dx plus x squared minus x second squared y dx is equals to 0. So, dito, kailangan nating alamin kung alin ba dyan yung m at kung alin yung n. So, base dun sa isang formula na binigay natin kanina, ang m ay with respect sa x at ang n ay with respect to y. So, dito, madali nating masasabi na ang m natin ay ang 2xy minus tangent y dx at ang n naman natin ay ang x squared minus x second squared y dy. So ngayon, para ma-solve naman natin ang value ng m, gagamitin natin yung formula na ito at i-derive naman natin siya. So, the partial derivative of m with respect to y is equals to the partial derivative with respect to y, 2xy minus tangent y. So, pag dinerive naman natin siya, dahil with respect to y siya, all variable aside from y will be treated as constant. So, yung 2x natin, dahil katabi siya ng y natin, yung 2x ay magiging constant na pwede nating ilabas. At ang derivatives ng y is 1. Minus, ang derivatives ng tangent y is second squared y, 1 partial derivative of y. Therefore, ang final answer natin ay magiging 2x minus second squared y. Ngayon, doon naman tayo kung paano masosolve ang value ni n. Sa pag-solve naman ng value ng n, i-derive naman natin yung x squared minus x second squared y. Tapos, eto na siya. So, pag-derive natin siya, ang mangyayari naman ay yung variable na walang kinalaman sa x ang magiging constant. So, dito, x squared ay magiging 2x. Bakit? Kasi kapag ibinaba mo yung exponent na 2, magiging 2x and 2 minus 1, base dun sa rule natin sa derivatives, magiging 1 kasi 2 minus 1 and magiging 1 yung exponent minus ang second squared y ay walang kinalaman sa x. So, ang mangyayari, matitreat natin siya as constant and mailalabas natin siya. Ang derivative ng x is 1. So, therefore, our final answer will be 2x minus second squared y. Dito, mapapansin natin na ang m at n natin ay magkamuka. So, ibig sabihin, isosolve naman natin yung f para makuha yung exact differential equation. Kasi dito, tinetest pa lang natin kung magkamuka ba sila, kung possible ba na makuha yung exact differential equation sa kanila. Ayan. Dahil nalaman na natin na pwede ang example natin, magpo-proceed na tayo sa pag-i-integrate. Gagamitin natin yung formula na may kinalaman sa m. Doon muna tayo dun sa may m. So, the partial derivative of f with respect to x is equals to m with x and y component. Isa-substitute lang natin yung m dun sa formula natin. So, magiging partial derivative of f with respect to x is equals to 2xy minus tangent y. Partial derivative of x natin is i-cross multiply lang natin. Remember na mayroong over 1 dito. So, ang mangyayari, partial derivative of f is equals to 2xy minus tangent y partial derivative of x. So, dito, i-integrate na natin sila. Ang integral ng partial derivative of f is just f equals to integral of 2xy partial derivative of x minus tangent y, the integral of tangent y partial derivative of x. So, mapapansin natin na yung 2y ay walang kinalaman sa x, so pwede natin siyang mailabas. 2y integral of x partial derivative of x minus yung tangent na walang kinalaman sa x ay mailalabas din natin, kaya magiging tangent y integral of just partial derivative of x. So, dito naman, mag-proceed tayo sa next step na isa-substitute na natin yung mga value ng integral natin. F is equals to y x squared over 2 na pwede nating makancel. So, pag kinancel natin siya, ang matitira ay x squared times y minus tangent, ang value ng partial derivative of x natin is just x. Therefore, our final answer will be f is equals to x squared y minus x tangent y plus py. So, bakit tayo nagkaroon ng py? Yung py natin, dyan, ay yung constant natin. Bakit natin siya kailangan lagyan ng y? Kasi, dito sa part na to, sa pag-i-integrate natin, di ba tinatanggal natin yung mga value na walang kinalaman dun sa x natin, na ilalabas natin siya, itinitreat natin ng constant. So, kung meron tayong y dito at inintegrate natin siya, pwede natin siyang ma-cancel out kasi constant siya. Eh, di ba kaya nga tayo naglalagay ng c dito kasi meron tayong constant. So, pwede na natin siyang palitan ng py. So, doon naman tayo sa next step. So, para makuha naman natin yung sa part ng n, gagamitin naman natin yung formula na may kinalaman sa n. Ito yung partial derivative of f with respect to y is equals to n with x and y components. So, dito, isa-substitute lang natin yung n dun sa formula, yung n dun sa formula natin. Ang mangyayari ay partial derivative of f over y is equals to x squared minus x second squared y. So, kagaya nung kanina nating ginawa, i-cross multiply lang natin. So, magiging partial derivative of f is equals to x squared minus x second squared y partial derivative of y. So, sa part na to, i-integrate na natin. The integral of partial derivative of f is equals to the integral of x squared minus x second squared y partial derivative of y. Tapos dito, the integral of partial derivative of f is just f is equals to integral of, pinaghiwalay na natin sila, integral of x squared partial derivative of y minus integral of x second squared y partial derivative of x. Tapos dito naman, makikita natin na pwede natin ilabas yung mga constant, yung mga walang kinalaman sa y. So, yung x squared natin, pwede natin siyang mailabas, magiging, at yung x natin, pwede natin siyang mailabas. So, magiging f is equals to x squared, integral of partial derivative of y, minus x, integral of second squared y, partial derivative of y. Tapos, i-substitute na natin siya. So, magiging f is equals to x squared, ang integral ng partial derivative of y is just y, minus yung constant natin na x, at yung integral ng second squared y is just tangent y. Therefore, our final answer will be f is equals to x squared y is minus x tangent y plus jx. So, bakit naman tayo ulit nagkaroon ng jx? Kasi, di ba, kadalasan kapag nag-i-integrate tayo, meron tayong nilalagay sa dulo na plus c. So, eto nga yun ulit, kagaya nung kanina kong sinabi. So, dahil nakuha na natin yung value ng dalawang f natin, ay it's time na para i-equate natin sila. So, yung x squared y minus x tangent y plus jx is equals to x squared y minus x tangent y plus py. So, dito, magka-cancel na tayo kung alin yung mga magkakamuka sa kanila. So, mapapansin natin na yung x squared y ay meron din sa kabila nung equal. So, cancel, at yung x tangent y ay meron din sa kabila. So, ika-cancel out na din natin yon. So, ang matitira ay yung x at yung y natin. Na, dun din natin malalaman kung ano yung magiging equal nila. So, yung py natin ay equal sa 0 dahil wala namang natira dun sa kabila ng equation, at ang jx natin ay 0 din dahil walang natira dun sa kabilang equation kasi na-cancel out natin. Therefore, our final answer or the exact differential equation of 2xy minus tangent y dx plus x squared minus x second squared y dy is equals to 0 will be c is equals to x squared y minus x tangent y. This is the final answer. So now let's proceed with the other example. Ngayon, mag-proceed naman tayo sa example number 4. Meron tayong 2xy dx plus x squared plus y squared dy is equals to 0. So, ngayon, kailangan nating malabel or kailangan nating malaman kung alin ba yung m at n natin. Alam natin, ang m ay with respect sa x at ang n ay with respect sa y. So, simply by looking at our equation, makikita natin ang m natin ay ang 2xy dx at ang n natin ay ang x squared plus y squared dy. So, ngayon, isolve na natin yung for n. So, gagamitin natin yung equation na ito na kung saan the partial derivative of m with respect to y is equals to the partial derivative with respect to y, 2xy. So, let's derive 2xy. Dahil with respect to y, any variable na hindi y ay ititreat bilang constant. So, yung 2x natin ay magiging constant, tapos ang derivative ng y is just 1. Therefore, our final answer would be 2x. So, doon naman tayo sa for n. So, hanapin naman natin yung value ng n natin gamit yung equation na x squared plus y squared dy is equals, tama. 1, 2, 3, go. So, ngayon, hanapin naman natin yung value ng n natin gamit yung x squared plus y squared dy. So, kapag dinerive natin siya, we'll come up with the equation na partial derivative of n with respect to x is equals to the partial derivative with respect to x squared plus y squared. So, dito naman sa part na to, lahat ng variable na walang kinalaman sa x ay ititreat mo bilang constant. So, automatically, yung y squared natin dito ay magiging constant dahil wala siyang kadikit na kahit anong x. So, kapag dinerive natin siya, yung x squared natin ay magiging 2x plus 0. Bakit siya naging 2x? Kasi kapag binaba natin yung exponent na 2 at kinapin natin yung variable na x, 2 minus 1, kagaya ng nasa rule sa derivatives, magiging 2x plus yung constant nga natin kanina na y squared ay magiging 0. Therefore, yung final answer natin ay magiging 2x. So, dito mapapansin natin na magkamuka yung value ng m natin at value ng n natin. So, ngayon, pwede na tayo mag-proceed sa paghahanap ng f or ng exact differential equation. So, sa paghahanap ng f, gagamitin din natin yung m at n natin. So, magsimula muna tayo sa m. Gamit yung formula na partial derivative of f with respect to x is equals to m with components of x and y. So, isa-substitute lang natin siya. So, the partial derivative of f with respect to x is equals to 2xy. So, ang mangyayari dito is i-cross-multiply lang natin siya, and ang mangyayari is the partial derivative of f is equals to 2xy partial derivative of x. So, dito naman sa part na to is in-integrate na natin siya. So, the integral of the partial derivative of f is just f is equals to the integral of 2xy partial derivative of x. So, dito mapapansin natin na magkakasama pa yung ibang variable. So, pwede pa natin siyang mailabas. Meron tayong constant na yung mailalabas. And ano yung constant na yun? Yung pwede nating mailabas ay yung variable na walang kinalaman sa x natin. So, automatically, yung 2y ay pwede nating mailabas. Na ang mangyari is f is equals to 2y integral of x partial derivative of x. So, ang dito naman sa part na to, i-equate na natin or isa-substitute na natin yung value nung in-integrate natin dito. So, mangyayari is equals to 2y, yung constant natin ay binaba lang, tapos yung value ng in-integrate natin dito ay x squared over 2. Bakit? Kasi sa integral, ang mangyayari, imbes na magma-minus ka, kagaya ng sa derivative, sa integral kasi ay plus 1, yung exponent natin na 1, plus 1 pa ulit, over yung 1 plus 1. So, ang mangyayari, x squared is equals to 2. So, ang final answer natin dyan ay mangyayari f is equals to x squared y plus py. So, instead na gamitin natin yung c dito, ginamit na natin yung py kasi alam natin na dahil ang with respect dito sa x, so automatically, yung py natin, dahil wala siyang kinalaman sa x, makakancel siya or matitreat siya as constant. So, sa pag-solve naman ng f, gamit yung n natin, gagamitin natin yung the partial derivative of f with respect to y is equals to n with x and y component. So, isa-substitute natin siya, magiging the partial derivative of f with respect to y is equals to x squared plus y squared. So, i-cross multiply natin, magiging the partial derivative of f is equal to x squared plus y squared partial derivative of y. So, kapag in-integrate na natin sila, ang partial derivative of f is magiging f lang is equals to the integral of x squared plus y squared partial derivative of y. So, pwede na natin silang paghiwalayin. And remember na ang with respect dito ay y. So, any variable na walang kinalaman sa y ay magiging constant. Just like x squared. Yung x squared natin ay wala namang kinalaman, so pwede natin siyang mailabas. Integral of the partial derivative of y plus integral of y squared partial derivative of y. So, after natin siyang ma-integrate, isa-substitute na natin yung mga value na in-integrate natin. So, magiging x squared, yung value ng integral of partial derivative of y is just y plus y2 plus 1 over 2 plus 1. Kagaya nga nung sinabi ko kanina, yung exponent natin ay dadagdagan natin ng isa at yung nasa ilalim natin ay kagaya lang din ng exponent na dinagdagan natin kagaya dito. So, the final answer will be f is equals to x squared y plus y raised to 3 over 3 plus jx. So, dito sa part na to, jx naman kasi ang tinitreat naman natin dito na may respect is yung y. So, anything or any variable na walang kinalaman sa y ay ititreat as constant. So, automatically, yung jx natin dito dahil walang kinalaman sa y, magiging constant siya. At mas madali nating malalaman kung ano yung mga value nila sa susunod na step na gagawin natin. So, yung nakuha natin na value ng mga f kanina, na f is equals to x squared y plus py at yung f is equals to x squared y plus y raised to 3 over 3 plus jx ay i-equate na natin. So, magiging x squared y plus py is equals to x squared y plus y raised to 3 over 3 is plus jx. So, dito mapapansin natin na yung x squared y ay magkamukha. Ika-cancel na natin sila. So, makikita natin na ang natirang value sa kabilang side ay y raised to 3 over 3. So, yung py natin ay magiging y raised to 3 all over 3. And yung jx naman natin, dahil walang natirang value dun sa kabila, ang sagot naman dun ay jx is equals to 0. Therefore, our final answer will be C. The exact differential equation of 2xy dx plus x squared plus y squared dy is C is equals to x squared y plus y raised to 3 all over 3. So, thank you for listening and sana may natutunan kayo. Salamat!
So we're going to talk about exact differential equation. A DE is said to be exact if we attain this condition. This was called test for exactness. So the partial derivative of m with respect to y is equals to the partial derivative of n with respect to x. So this m and n compose a function of x and y. So the difference between those terms is m is associated with the dx and n is associated with the dy in a given differential equation. So we're going to use this formula if we want to test if the DE is exact and if both term is equal to each other. So it means the DE is exact. So after we test the DE for its exactness, we're going to use this formula to solve for the exact DE, wherein the partial derivative of f with respect to x is equals to the function of m, x, and y, and the partial derivative of f with respect to y is equals to the function of n, x, and y. So this formula is for you to solve the exact DE, where f is the solution to an exact DE. So let's try to solve this example. Example 5. Test x plus y cosine x dx plus sine x dy is equals to 0 for exactness and solve. So as we all know, the term containing x and y with respect to dx is m. And the other term with respect to dy is n. So we're going to use this formula to test for its exactness. So we're going to test this condition. Partial derivative of m with respect to dy is equals to partial derivative value ng m x plus y cosine x with respect to dy. So in this case, we're talking about partial derivatives. So any variable aside from y is treated as constant. So x here will be constant. Derivative of x, derivative of constant is 0 plus y cosine x with respect to dy. Cosine x here is constant. So it will become cosine x derivative of y 1. So partial derivative of m with respect to dy is equals to cosine x. So another condition, partial derivative of m, n with respect to dx, partial derivative ng value ng n sin x with respect to dx. Derivative of sin x is cosine x. So we can say that this differential equation is exact. Therefore, this differential equation is exact. After we test the exactness, we will arriving in this formula to solve for the exact dE. So, partial derivative of f with respect to dy is equals to n x and y. So, value ng n is sin x. Partial derivative of f with respect to dy sin x. After this, cross multiplication, partial derivative of f is equals to sin x dy. After this, we tend to get the f, which is the solution of this dE. So we need to integrate both equation. So we are now arriving to the solution f. F is equals to integral of sin x dy plus q of x. Q of x, or simply c. F is equals to integral of sin x dy y cosine x plus q raised to 1 x. So we can now equate the solution f to the other term m. f is equals to m. Equate f to m. The solution f, q of 1 of x plus y cosine x is equals to m x plus y cosine x. So in this equation, we can now cancel y cosine x. We can now arrive to the value of q1 of x is equals to x. So in order to know the value of q of x, we need to integrate x. So q of x is equals to x squared over 2. After this, we can now substitute the q of x to the original solution f. So f is equals to y sine x plus q of x is equals to x squared over 2 is equals to c. So simplify this, equate both equation to 2, cancel 2y sine x plus x squared is equals to c. So here is the solution to the given DE. So let's try again another example. Example 6. Test the equation ye raised to xy minus 2y raised to 3 dx plus xe raised to xy minus 6xy squared minus 2y dy is equals to 0 for exactness, and find its particular solution when x is equals to 0 and y is equals to 2. So on the previous example, we can now determine the m and n. M is ye raised to xy minus 2y cubed, and n is equals to xe raised to xy minus 6xy squared minus 2y. We can now proceed to this condition where we are going to test if this differential equation is exact. First, partial derivative of m with respect to dy is equal to partial derivative m is equals to y e raised to x and y minus 2y cubed with respect to dy. So this will become ye raised to xy times x, the constant here, minus the inside term e x raised to 1, then the derivative of y is equals to 1 minus derivative of negative 2y cubed negative 6y squared. So partial derivative of m with respect to dy is equals to ye raised to x and y times x ye raised to x and y minus e raised to x and y minus 6y squared. Next condition is partial derivative of n with respect to dx is equals to partial derivative of x e raised to x and y minus 6x y raised to 2 minus 2y with respect to dx. So it will become xe raised to x and y here, the constant with respect to dx will become y plus the inside function e x and y, the x here will become 1 derivative of x minus 6y squared constant, and x here will become 1 with respect to dx minus 2y here is constant, so it will become 0. So partial derivative of n with respect to dx is equals to x y e raised to x and y plus e raised to x and y minus 6y squared. So it is obvious that our differential equation is exact. Therefore, our differential equation is exact. After we test the exactness of this differential equation, we can now proceed to this formula. Partial derivative of f with respect to dx is equals to the function of m, x, and y. So partial derivative of f with respect to dx is equals to value ng m, y, e raised to x and y minus 2y cubed. So cross multiplication, partial derivative of f is equals to y e raised to x and y minus 2y cubed dx. So in order to get the solution f, we need to integrate both equation. So f is equals to integral of ye raised to xy minus integral of 2y cubed dx. F is equals to ye raised to x and y with respect to dx is equals to e x y minus integral of 2y cubed with respect to dx is equal to 2x y cubed plus p of x. So we need to differentiate this equation with respect to dx. F is equals to e raised to x and y x minus 2x 3y raised to 2 plus p of x or c. So it will become f is equals to xe raised to x and y minus 6x y squared plus p raised to 1 x. So after that, we need to equate f to the function n. f p raised to 1 x plus x e raised to x and y minus 6 x y squared is equal to n x e raised to x and y minus 6 x y squared minus 2y. So we're going to cancel xe raised to x and y, negative 6 xy squared. So we're going to obtain p raised to 1 x is equal to negative 2y. So in order to get the p of x, we need to integrate the value of p1 of x. So it will become negative y squared. After that, we need to substitute the value of px to the original solution of f. F is equal to e raised to x and y minus 2x y cubed, and the p of x, negative y squared, is equal to c. So this is the general solution for this differential equation. On this differential equation, take note that we have a condition which x is equal to 0 and y is equal to 2. X is equal to 0 and y is equal to 2. So the equation becomes e x is 0, y is 2, minus 2, 0, 2 raised to 3, minus 2 square is equal to c. So e raised to 0 and 2 is 1 minus 2 times 0 times 2 raised to 3 is 0, minus 2 raised to 2 is 4. So 1 minus 4 is negative 3. Thus The solution that satisfies the given condition is e raised to x and y minus 2x y cubed minus y squared plus 3 is equal to 0. So this is the particular solution.